Good morning once again, and today we will continue with what we have started last time on quadratic functions. Okay, and today that will be in connection also with the minimum and maximum values of a quadratic functions. Okay, so that will be page 56 to 58 of your book. Okay, so if you want to have a guide, if you want to check, if you cannot fully understand with the discussion, then you can refer also that discussions on your book, okay, in your book, and that is page 56, all about maximum and minimum values of quadratic functions. Okay, so take note that last time we learned that if the coefficient of x is positive, okay, take note, standard formula or standard equation for quadratic function is ax squared plus bx plus c. Now, if the coefficient of x squared is positive, then the parabola, okay, the graph of the parabola is opening upward. And if the coefficient of x squared is negative, then the parabola will open downward, okay, with a maximum value. Now take note, maximum is the highest in the graph for a graph opening downward. And for a graph opening upward, we have that called minimum values, okay? So how do we find out, or how do we solve now maximum and minimum values of quadratic functions? Okay, so again, coefficient of x squared is positive, then parabola opens downward like letter U with a minimum value, okay, or a minimum point. And then if the coefficient of x squared is negative, so it is like letter N, your parabola is like letter N opening downward with a maximum values. Okay, so today we will now focus on this maximum and minimum values of quadratic functions. How to find and how to solve the maximum and minimum values. Okay, so let me share with you this one. Okay, so one moment so that it can now show the PowerPoint. Okay. Okay, so there you have it on your screen, finding minimum or maximum values with regards to the quadratic functions. Okay. Okay, what happened? Okay, there you go. It is quite loading the internet. I don't know what happened. Okay, can you hear me? Can you hear everyone? Toon, can you hear me? Pawan, is it okay? Can you hear?
Yes.
Can you see on the screen?
Yes. I can see.
Okay, I'm not sure because on my screen, it is only the PowerPoint and I could not see your face. Okay, so anyway, let us just continue in this finding minimum or maximum values. Again, that is page 56. Now, if you are given the function of x equals negative 3x squared plus 2x. Okay, minus 4. So here it is your so the function of x, negative 3x squared plus 2x minus 4. Then we can substitute that one and find the, take note, you have here the coefficient of your x squared is negative 3. Okay, since this is negative, then therefore if we plot it in the graph, then the parabola is opening downward like a small letter N. Okay, so again, since that is a negative, therefore our parabola will open downward. Okay, so today we will have to find the maximum. Okay, take note, in a parabola we have here the maximum, and if that is like a letter U, then you have there the minimum. Okay, so that will be our task today, to find the values, the maximum and the minimum values of quadratic functions. Okay, so given this example, negative 3x squared plus 2x minus 4. Okay, so that is our quadratic equation. Okay, so step 1, determine whether the function has a minimum or maximum value. Okay, so that is step 1. So as I have said, since the coefficient of x squared is negative 3, again, so just to emphasize, since the coefficient of x squared is negative 3, therefore the graph opens downward, as I have said, and of course will have a maximum value. Since it opened downwards, so therefore it has the highest or the maximum value on the graph. Okay, next, step 2, find the x value of the vertex. Okay, again, we go back to that one. Okay, here. So as we said, it will open downward with a maximum value. And then, how to find the vertex? Take note, the vertex is the meeting point of the axis. So for example here, and we have this. So the maximum point is here. So therefore, this will be the vertex or the meeting point in the highest or in the maximum value. So how to get the vertex? We have there the formula x equals negative b over 2a. Again, take note of that formula, x equals negative b over 2a. That is how to get the x value of the vertex. Now, to substitute, okay, so you have here a. Okay, so take note, that is our a. And then bx, take note, ax squared plus bx. For b, we have here, okay, so that is b in our equation. And of course, you have there your c. Okay, so c is this one. Okay, so using or substituting x equals negative b over 2a, we substitute so that we can get the x value of the vertex. So therefore, substituting that one, we get b, which is 2. So you have here substitute b, which is 2, over 2a. And take note, a is -3. So therefore, 2 times -3. Okay? So you have now there 2 over 2 times -3. So we have there 2 over -6. And since we have here a negative sign, 2 over 6 reduced to lowest term equals 1/3. Okay? So -2 over 6. And still we have the negative sign outside. So that is why we get 1/3, positive. Okay? So therefore, the x now, or the vertex, or the x value of the vertex is, we have here positive 1/3. Okay? Okay, so next. Another example. Okay, so again, we have that example, -3x squared plus 2x minus 4. And then the x, or the vertex, is, we have there 1/3. Okay, so to continue, find the minimum or maximum value of the function of x. The same. Okay, using the same example, we get the minimum or maximum. Okay, so we have here, take note, 1/3. Okay, the answer was 1/3. So therefore, function of x, okay, replacing. Okay, function of x, we have here fx. We said that the vertex for, or the x value of the vertex is 1/3. So f 1/3 equals -3 x squared. Okay, here please follow. Okay, so you have here -3 x squared, and we said x is 1/3. So -3 times x squared plus 2 times x. Again, x is 1/3. Minus 4. Okay, so that you have here -1/3 plus 2/3 minus 4 equals 11/2. Okay, take note, they now have same denominator. 1 squared is 1 times -3 is -6. Okay, so you have here now the answer, -1/3 plus 2/3. Okay, here 2/3 minus 4. Okay, equals 11. Take note, 4 has denominator of 1. Okay, so that will be converted so that they will have same denominator of 3. So that is times 3 and then times 3 also. So that they will have same denominator of 3. And then we can now perform the operation. -1 plus 2 minus 12 and over 3. So therefore, we get now the function -11/3. Okay, so please follow. This is a quite difficult. And then next, the maximum value is -11/3. So the domain is real numbers R, and then the range is all real numbers less than or equal to -11/3. Okay, so again, the minimum value is 1/3. and the maximum value is negative 11 over 3. Okay, so if we try to picture it out, that will be opening downward. Okay, and the maximum value is negative 11. Okay, 0.3. 11 over 3, sorry. And then the minimum value is, we have there 1/3. Okay, so if we check, we have there the function of x, the example that we have, negative 3x squared plus 2x minus 4 on the graphing. Okay, so we don't use graphing calculator. Okay, so if we try to check that one, since we don't need to use graphing calculator, so we can have just a picture of it. Okay, so maximum is 1/3, or for the x, maximum is 1/3 or 0.333. Okay, so that will be in this part. Okay, so again, 1/3 is of x is, it will be in this part, and then y is negative, okay, negative 11 over 3 is negative 3.666. So that will be in here. So the x, if this is your x and this is your y, 0.33. So we have it in here. So the maximum values of that quadratic equation. Okay, so again, it is opening downward. So we have that maximum values in here. Okay, so again, that is in application of a calculator, but we do not use calculator, so we just presume to divide 1 over 3, that is 0.3333, and we have also negative 11 over 3, we have negative 3.66667. Okay, so that is if we use the calculator for checking. Okay, so one more example on finding the maximum and the minimum values. Now here, let us take into consideration this quadratic function. Fx, okay, fx equals x squared minus 6x. Okay, but before that one. Okay, before that one. Ton, are you there? Otto? Bas, are you there? Frau? P, Pawan? Kemuk? Dean? Kang? Okay, any one of you please unmute. Okay, P, thank you. You are there. What about the others? Otto, are you there? Otto? Oh.
Yes.
Yes. Okay. What about the others, Pawan? Frau?
Yeah, I'm here.
Yeah, okay. What about Kemuk? Kemuk? Are you there, Kemuk? OMG. Kemuk, are you there? Yes. Okay. What about Dean?
I'm here.
Okay. So just please follow. I'm sure you are still confused. Okay. So please follow so that we can get the maximum and minimum values. Take note, we get the maximum if the coefficient of x squared is negative. So we get the maximum value for x and y coordinate. Okay. And then we will get the minimum values if the coefficient of x squared is positive and the parabola will open upward. So we will get the minimum values of for the x and the y coordinate or intercept. Okay, so The first example was a negative number or coefficient for x squared. Now this time, it will be a positive number. The coefficient of x squared is a positive number. Therefore, the parabola will open upward and we will get the minimum values of the x and y intercept. Okay? So this is now the opposite of the other one. Okay, so please follow so that we can get it a little bit so that we can get also on how to get the minimum or the maximum value. Now, in this example, we have here the function of x, okay, equals x squared minus 6x plus 3. Okay, so take note, the coefficient of x squared here is 1, and that is positive 1. So therefore, if that is positive, that coefficient is positive, then our parabola will open upward. So we will get the minimum value of the x and the y intercept. Okay? Again, the maximum is for negative coefficient of x squared, and the minimum here is for a positive coefficient of x squared. So therefore, in this example, we have x squared is having positive 1 as the coefficient. Okay, so that is our A, and bx. Okay, so b with the coefficient of x here is negative 6. So that is b. And of course, the c or the constant here is positive 3. So that is your c. Okay? So that when we will now find, okay, the value or the minimum value for x intercept, then step 1, we follow the same. Determine whether the function has a minimum or maximum value. So as we have said, since 1, the coefficient of x squared is positive, therefore, the graph opens upward and has the minimum value. Okay? So that is what we have just stated. Open, upward, have the minimum value or the lowest value, or that parabola we can get the lowest, the smallest value. Okay. Step 2, so that we can get the minimum value or the value of the x-intercept, we use again that formula, negative b, okay, negative b over 2 times a, so that we can get the minimum value of that x. Okay, so to replace, you have here negative and then b. B here is negative 6. Okay, so again, b is negative 6. So that is why we have that negative 6 over 2 times a. And we said a here is 1. Okay, it is presumed to have 1. So that is 1x squared. So we just say x squared. So therefore, you have here negative 6 over 2 times a. And we said a is positive 1. So that is why we have here b at 2 times 1. Okay? So we have now here negative 6 over negative 2. Okay, that is negative 6 over 2. And take note, we still have that negative sign outside this one here. So that is why we have here that will be equals to negative 6. Negative 6 over 2 is negative 3. Negative and negative will become positive. Okay, so that is why we have here 3, which is now the value of x. For the minimum value of x, we have there 3. Okay? So after that one, we find also the minimum value of the y-intercept or in the y-coordinate. Take note, this is the x. So the next step is we solve also for the y-intercept. Okay? So that is why same equation, we now find the y. Function of x equals x squared minus 6x plus 3. And then find the y-intercept. Okay? We said the value of x is 3. So we replace that value of x into our function. Okay, so we replace that one. So function of x. Function, we know already that x is 3. So function of x, which is 3, equals 3, okay, x squared. So we have here 3 squared minus 6. Okay, so just follow here this one. Okay, replacing the value of x minus 6. Okay, minus 6x, and you have here 6 times 3 since the value of our x is 3 plus 3 equals negative 6. Okay, so you have here 3 square is 9. Okay, minus 6 times 3 is 18. Okay, plus 3. Okay, combining this one, we have that one. 9 minus 18 is negative 9. And that plus 3, so that is why we get negative 6. And that will be for the function of the y-intercept. Okay, so we have now here the minimum value is negative 6. The domain is all real numbers. Okay, so we know that all of that are real numbers. So the range is all real numbers greater than or equal to negative 6, or for the y-intercept, then we have here y greater than or equal to negative 6. So therefore, negative 6, the higher number, okay, because that is greater than. So negative 5, negative 4, all of that can be part of the domain of the y-intercept. Okay? Okay, so let us... Okay, so we have now the value, the minimum value of function of x squared minus 6x plus 3. And the domain or the minimum value of x is equals to 3. And for the y-intercept, the minimum value is negative 6. And we said minimum. Okay, so try to understand. We said minimum. So therefore, this is the lowest. So the minimum value of y is negative 6 and higher because it opens upward. and the minimum for the y is -6. So therefore, the values could be -5, which is higher than 6, -4, -3, -2, 1, and 0, 1, 2, 3, and so on. Same is true with the function of, we said that the value of x is 3. So, but this is the minimum. So therefore, the other values could be 3 and 4. Okay, you can have 5, 6, 7, and so on with the range of values of the x. Because we said again that that is a parabola opening upward and x is equals to 3. Okay, here x is 3 and y is -6. Okay, so that will be the minimum value of x and the y intercept. Okay, so did you get a little bit? Ton, did you understand a little bit or confused? Ton? Ton, are you listening? Okay, did you get how to get the maximum and the minimum values? Ton? What about the others? Otto, did you get a little bit on that discussion? Otto? What about
Yes.
Temut? Okay, Otto, did you get how to get the minimum and maximum values of the function? Not yet. Okay, okay. So, let us try some. Okay. So, if that minimum value, if we try to put that one into or using a calculator, we said that x is 3, but in a calculator, actually, it will have 2.9994, the same with 3. And that is for x. And for y, okay, for y, we have there -6. Okay, because that will be -5.75, and that is just equivalent to -6. When x is 1.5, the value of y is -3.75. Okay, so this is how to graph. Okay, so if we put that one, we have here the minimum value of x is 3 and y is -6. That is the minimum. Okay, so if we put that one on a graph, the parabola will be looking like that. And the minimum value of x is, you have here, this is, okay, 3 and -6. Okay, so that we can put the value. If x is 2.5, then that will be, okay, 2.5, and that will be -5.75. Okay, or if 3.5, then you can have it in here, so that it will, okay, this will represent now in the parabola. Okay, so actually I have a hard time on how to explain it, especially that this involves solving. So that's why I really need to let you understand the minimum or the maximum value. Okay, just like for this example, we have here the function of g, x equals negative 2x squared minus 4. Okay, so following the same example that we have, as we said, we have here the coefficient of x squared is negative 2. So therefore, the parabola will open downward. Okay, so you have here the coefficient of x, and that is a, and you have the b is 0, and c is, okay, c is negative 4. Okay, so that if we solve that one, again, the parabola will open downward. Okay, because a, the value of x squared, the coefficient of x squared is negative 2. So step 2, find the value of x of the vertex or the meeting point of the y and the x intercept. So you have there the formula again, negative b over 2a. So that we said b here is 0. So you have there 0 over 2 times a. 2 times negative 2 is negative 4. And of course, if we divide that one, 0. So here, the value of x is 0. Okay? And then, we will now find the value for y. Okay? The maximum value of y. So we said here is our function of g. So therefore, we have here the function of g or x, we said is 0. So you have here negative 2 times 0x squared minus 4. Again, so we replace the value of x, which is 0. So that is why we have here negative 2 times, and then we